So I'm looking at Peano's axioms. In particular, Peano's fifth axiom. So it can be formulated in several different ways, but off of the Wikipedia article for pre-intuitionism, under the heading "The Principle of Complete Induction." This sense of definition allowed Poincaré to argue with Bertrand Russell over Giuseppe Peano's axiomatic theory of natural numbers. Peano's fifth axiom states, allow that 0 has a property p. That's your first part of it. And if every natural number less than number x has a property p, then x also has a property p. Okay, so these are definitions. These are things that we're just axiomatically assuming. Therefore, every natural number has the property p. Okay, so there's definitely problems with this, right? So Poincaré noted problems with this, right? And here's what he's saying. This is the principle of complete induction, which establishes the property of induction as necessary to the system. Since Peano's axiom is as infinite as the natural numbers, it is difficult to prove that the property of p does belong to any x, and also x plus 1. What one can do is say that if after some number n of trials that show the property p conserved in x and x plus 1, then we may infer that it will still hold to be true after n plus 1 trials, but this itself is induction, and hence the argument is a vicious circle. From this, Poincaré argues that if we fail to establish the consistency of Peano's axioms for natural numbers without falling into circularity, then the principle of complete induction is not provable by general logic. Thus, arithmetic and mathematics in general is not analytic but synthetic. Logicism thus rebuked, and intuition is held up. What Poincaré and pre-intuitionists shared was the perception of a difference between logic and mathematics that was not a matter of language alone, but of knowledge itself. And I actually think we can take this slightly further. So looking at sort of another version of the axiom laid out. So this is under the Wikipedia article, Peano Axioms. Towards the beginning, where are we? Yeah, the first heading, historical second order formulation, down a little bit, number 9. Right above it, it says the intuitive notion of each natural number can be obtained by applying successor, the operation successor, sufficiently often to 0, requires an additional axiom, which is sometimes called the axiom of induction. So this is just going to be another formulation of the same thing. 9. If k is a set such that 0 is an element of k, and for every natural number n being in k implies that the successor of n is also in k. Thus, k contains every natural number. Now, I have a problem with this, because if we look at what this means, the successor function, so successor function is like this, right? So s of some value n is n plus 1, okay? But what we're doing here, and then, that gives us things like s of 1 is 2, s of 2 is 3, etc. Alright, gives us all of that shit. Problem is, you have to open up somewhere. You have to start somewhere, right? So, where's your starting point? And if our starting point is 1, which is what Peano originally did, then 0 is not in the set of natural numbers. And if our starting point is 0, then we can't actually define 1, because we have to separately indicate what 1 is. So now we have to indicate what 0 is and what 1 is separately in order for this to make any fucking sense, right? Because if we start with 1, well, okay, we're good, because there's 1. If we start with 0, we have to define both 0 and 1. You have a problem here. Also, what the fuck is this? Right, so there's my cursive question mark. What is 1? Right, and this is a very serious question, right? So they're going along assuming a bunch of shit that the intuitive sense of 1 makes sense, right? That we can just assume that, and they're intending to debunk intuitionism via this intuitionistic sense of this value, right? So this is a successor function, right? The whole point of it is that we're looking at a sequence so that each element has a successor, and what we're doing is we're adding this thing to it each time to get that successor. Well, if we start with 0, right? So start with 0. Okay. Here's our successor to 0, or 1. What happens when we get, where do we go? How do we get there? How did we move this far? Why did we go that far? Couldn't we have gone any distance and it would still be this? And if we can go any distance and it's still this, is this even defined? So if this is the successor to 0, then can't we say that this is the successor to 1? And which is 2. And this is the successor to 2, which is 3. And this is the successor to 3, which is 4. And this is the successor to 4, which is 5. And this is the successor to 5, which is 6. Right? So what is 1? This is a very valid question, but this isn't something that's handled. We just assume, like, oh, we know what 1 is. Do we? Like, why is that not okay? Because 1 is just some distance. We're just moving some positive distance, right? You have to accept that that's necessarily true from 0, right? Because if we start at 0 and all we're doing is adding 1 to it, well, I don't know what 1 is. I don't know what that distance is. So I have to just say, well, we moved some distance. Okay, well then, if I move some distance, then this is true, and this is true, and this is true, and this is true, and this is like, these are all equally true. Or 2 could be here, or 2 could be here, or 2 could be here. It could be anywhere, as long as it's after this point, we've moved some distance, right? And it gets worse, because if we start at 1, so here's 1, what ends up happening, so here's our origin. Our successor to 1. So now we've defined what 1 is. 1 is this far. So this is now 2. So what we've done is we've doubled where we're at. So the successor to 2 can very validly be thought of as over here. So 3 is twice 2, and 4 is twice 3. This is a valid way to look at this. If what we do is we start off with 1 as our initial thing, and if we start off with 0 as our initial thing, and we don't properly define what 1 is, this works. This is valid. And if we start with 1, this is also valid. Because what we can say is that what 1 is, oh, it's as far as we've already gone. So if we're at 2, well, 1 is as far as we've already gone. So there you go. And if we're at 3, then if we're at 2, where the hell am I? So yeah, if we're at 1, then the successor to that, we just go as far as we've already gone to get there. Okay? And then the successor to that, we just go as far as we've already gone to get there. And then the successor to that is we go as far as we've already gone to get there. Right? This is consistent. This is a consistent way to look at this. But this does not give you the natural numbers. So this approach to getting the natural numbers does not work. It objectively, these rules are insufficient to actually accomplish what everybody is saying that they can accomplish. And I find that very, very interesting. What you need to do is you need to define your unit. You need to go outside of numbers in order to get your numbers to make sense. You actually have to go outside of what we're considering to be mathematics. Mathematics is not about numbers. What P&O is trying to do, and the entire formal movement was trying to do, was make mathematics about numbers. But I've shown multiple times in multiple different ways that is not true, right? The mathematical operators work over units and vectors just as well as they do over scalar numbers. So trying to make the foundation about scalar numbers, like natural numbers, initially and then grow it from there, won't work because that doesn't actually explain why it'll work over units. You can never get to an explanation that way of why the mathematical operations can work over units, why you can convert centimeters to inches by dividing by centimeters. So now you have centimeters divided by centimeters, those cancel, and now you have it in inches. You can't explain that unless you're properly handling what the fuck 1 is in the first place. And here, this only makes sense if we handle, in terms of knowledge, what the unit is that we're talking about. And we have to deal with commensurate units within this space. So it's not about numbers. You cannot start with numbers, I'm pretty sure. I don't think you can start with numbers and grow it from there. That won't work.